In this video, we'll be having a look at the following problem. Prove that for all positive integers n, that the identity sum from k equals 1 to n of -1 to the power of k minus 1 times k times n choose k equals to 0. So we have to prove this identity for all positive integers n. If you like, you can pause the video and have a go at the problem yourself before we have a look at the solution. Okay, let's have a look at the solution. So we will consider the function f of x equals x plus 1 to the power of n. And we'll do something interesting with this function. So what you can see is that we can expand out x plus 1 to the power of n and apply the binomial theorem. So when we apply the binomial theorem, we get the sum from k equals 0 to n of n choose k times x to the power of k. So this is the binomial expansion of f of x. Now, the interesting part is what happens if we take the derivative of both sides. So this equation and this equation in x, if we take the derivative in terms of x. So if we take derivative of x plus 1 to the power of n, using the power rule, we get n times x plus 1 to the power of n minus 1. We can also find the derivative of f of x by taking derivative of this summation. So again, we can apply the power rule, but this time we bring down the k. So x to the k becomes the kx to the k minus 1. And we also have the n choose k coefficient. But what we can see here is in this note, when k equals 0, so in f of x, when k equals 0, you get the constant term of n choose 0. So the derivative will just be 0 for this constant. So there will be no term in the derivative when k equals 0. So we can actually just start the sum at k equals 1. Now, the next interesting part is when we substitute x equals minus 1 into both expressions for the derivative. So the simple expression we get is when we put -1 here, it just becomes -1 plus 1, which is 0. So you get 0 using this expression, but using this expression over here, you get something interesting because when you put x equals minus 1, you get the sum from k equals 1 to n of k times n choose k times -1 to the k minus 1. And in fact, this is the same as this expression over here. Yeah, so what this means is this is enough to prove what we wanted to prove, which was the summation of -1 to the power of k minus 1 times k times n choose k from k equals 1 to n is equal to 0. So this completes the proof of this question. Okay, so that concludes the solution to this interesting problem involving binomials and an interesting proof that involves taking derivative of a function we constructed. So hope you enjoyed this video. Thanks for watching, and I'll see you next time.